Howdy. We are going to look at some pictures I made under the with the microscope from this piece, which I have been sending to the Finnish Geological Institute some time ago. And I marked this as number 8. So these are the samples I sent them. Number 7 and number 8. It is important because they got mixed up, obviously. Number 8 turned into number 7. And it's clearly marked number 7. But it's only marked here. There's nothing going on up here. For this to probably figure out, you have to go to the next page where you find this little mark, which could be number 7, but I don't know. So we maybe just assume that the lowest lines is the number 7, and I'm no chemicist or whatsoever they are called, chemistry people. I marked all those shortenings in their real names: magnesium, aluminium, silica, phosphorus, and so on. And there is like very accurate numbers. For example, potassium and calcium, which is something is very interesting. I'm still thinking about this very often. Iron and cobalt and nickel. And there's a next page, and now here we have this marked, which is zinc, obviously. It has a very high zinc constituent. But then also, for example, I want to point out that silver, it says LOD, but there's still 6. I don't know really what to make out of that. Maybe it's the other one. The molybdenum. Yeah, 6 molybdeniums, but no silver whatsoever. Low on data, or whatever that means. And if we continue with the list as it gets more interesting: gold, mercury, lead, bismuth, thorium, uranium, lanthanum. Lead, they are telling us. And I probably learned that everything which has been once radioactive turns, after some more altering, into lead. Which is very interesting to think about. But thorium or whatsoever, or gold, low on data. Which is probably, I don't know. Is it possible? Of course it is. Somehow a little bit strange. But we have some knowledge about this stone, if this is really a number 7. You know, they got mixed up. It's what to do. I have made a translation with Google Translate. Magnetic kitty as a weak pyrite. Yeah, that's Google translating. I don't know. It's probably really a little bit wrong translated. Radioactive minerals, no. No actions. The sample is a volcanogenic phyllite. The sample contains some magnetite and was measured with an X-ray fluorescence analyzer. Zinc is somewhat elevated. The result is attached. The sample would be interesting if there was a bigger piece. That's the sample piece, Google Translate. And so I Googled Phyllite. And Wikipedia provided me with this knowledge. Phyllite is a type of foliated metamorphic rock created from slate that is further metamorphosed so that the very fine-grained white mica achieves a preferred orientation. It is primarily composed of quartz, cerussite, mica, and chloride. Phyllite has fine-grained mica flakes, whereas slate has extremely fine mica flakes. And schist has large mica flakes, all mica flakes of which have achieved preferred orientation. Among foliated metamorphic rocks, it represents a gradation in the degree of metamorphism between slate and schist. The minute crystals of graphite, cerussite or chloride, or the translucent fine-grained white mica impart a silky, sometimes golden sheen to the surface of cleavage called phylitic luster. The word comes from the Greek phylon, meaning leaf. The protolith or parent rock for phyllite is shale or pellite or slate, which in return came from a shale protolith. Its constituent platy minerals are larger than those in slate but are not visible with the naked eye. Phyllites are said to have a texture called phylitic sheen, and are usually classified as having formed through low-grade metamorphic conditions through regional metamorphism, metamorphic phases. Yes, lightning, bolts, and electricity, which creates heat and will alter the elements. Transmutation of the elements. I also found a very interesting paper and many other things. I don't know where to continue now, but the place where I found that rock is Kuasalo, the plasma rock site. There's a playlist with more videos. I know that's not the best comparison. There should be more contrast or something added to the left picture because it has similar features. And it's somewhat 2.5 meters in diameter. And we have also these kind of features in Kuasalo. And if you watch that left picture, which is from the plasma rock site, and compare it to a picture I found in a very interesting article with the title Petrology, Geochemistry and Petrogenesis of A1 depleted comatite from Badam Pahar, Gorum Mahisani, Greenstone Belt from Eastern Iron Ore Group, Singhbum, Creighton, India. Now we have to scroll down a bit, but you can see I'm not cheating. This looks to some degree very much like some parts in the plasma rock site. And I think that's a coin, so that is rather small. Very interesting stone features they have in India. Foliation of phyllite is deformed and forms pucker folds. Folded quartz veins are noticed in the amphibolite. Radial cracks and chilled margin are preserved within pillowed metabasalt. Now that's geological texts. The thing is, they are talking about this is clay. Because I was also searching for olivine, and this is how I found this article. Spinfex petrogravure. And also here they talk about this metamorphism, but they never nowhere explain what it is, what they mean, what do they mean by this? And if they would tell what they mean by this, I also would like to know how it happened, because it doesn't seem that they know. Yeah, I don't find now this clay thing, but that's a very interesting article I found. I just wanted to show you that because I found something which looks rather similar to the plasma rock site where I found this other rock. Let's check out the pictures. So that's number 7, which has been in the office or laboratory of the Finnish Geological Survey. And you can see I took a little piece off of that. Here's another picture of that. I wanted to show you that there's like metallic features all over the place, bigger and smaller ones. So I glued it to this glass, and it was yesterday already very thin, but I still continued. So it's like the glass I tried to measure is approximately 1 millimeter thick. So this piece is a tenth of it, maybe even less. It's really thin. Now this is how it looks under the microscope. This has a quite metallic appearance. But actually not, it's just the light shining through. And these are just some first pictures. But I think it's very interesting because it is still, it sounds very funny or odd or whatever. Because I know how thin it is, which actually means I don't know how thin it is because I have no possibility to measure the thickness of that piece or whatsoever. It's very thin, but it's nonetheless still 3D. How much we have to grind down to get 1D, I don't know. And I don't have any filters. I have to try later to adjust, in a way, something. I try to use my fishing glasses because they are polarized. It would be interesting if there any effect happening if I polarize the light or try to polarize the light which is coming from down of the microscope. And I'm rather surprised of how bright that is because the whole stone looks rather black, and that's all white. Is this mica? What are we looking at? Crystal structures. And sometimes it's really easy. Just take out the microscope and put the phone there and start to watch because it's much easier also watch with a phone than with bare eye. At least for me. If it would be binocular or something, maybe it would be a different thing. But if you attach the phone, you can watch with both eyes and you can adjust also to some degree the brightness and these kind of things. And the only difference between this and this is the magnification. And I have to read again what's the magnification of that. 800 times is probably the biggest or something. There are these streaks which go through. Yeah, that's maybe the same. This might be the exact same picture, just increase the magnification. But I never remember. Yeah, that looks funny. Yeah, this seems to be rather sharp. Now, I really would like to know how big this would be, this one. Or like these things. What are we looking at? The thing is, I'm still trying to either confirm or debunk my claim that there could be petrified wood. There's something blue. Yeah, I haven't noticed that. Yeah, that's also again a different magnification. Maybe that's the lowest one. And it is very, very fine grained. Maybe I have to try to take some macro, macro pictures with from just the sample itself with the camera, no microscope included, just from the sample alone, because I think that's yeah, I know they are interesting. Otherwise, I wouldn't watch this. I probably wouldn't grind stones. I probably wouldn't make even videos, or if I wouldn't find this very interesting. There are all kinds of structures. Yeah, that's a little video, obviously, where I try to somehow pull forth the three-dimensional properties of this thing, despite its being very thin already. Yeah, I know everything is 3D, but so you just can somehow imagine, like, if you just look at one picture, you just see one layer. And if you have this kind of video, it's somehow, it looks like a kaleidoscope. Yeah, I have to show you still some pictures from this other article. How they take pictures of stones and identify exactly what they see. And A3 Anomalies Laboratories isn't equipped for these kind of things. There's no laboratory whatsoever. Just a kitchen table, grinding paper, and stones. Microphone. What is it? Microscope. Yeah, these were pictures of that stone from here. But now let's just go quickly back to the article. That's the article. Photomicrographs of spinifex zone, complete alteration of proxene to tremolite and olivine to serpentine, and secondary magnetite. Crisscross arrangement of serpentine and pyroxene's needles, alternate plates of pyroxene altered to tremolite and chloride, and olivine altered to serpentine, secondary magnetic and talc. Large olivine blades are now altered to serpentine, mostly antigorite, and secondary magnetite. Relict of primary clinopyroxenes within this altered mass of tremolites. Photomicrographs of cumulate zone. Cumulate zone display cumulus and intercumulus phases. olivine altered to serpentine and secondary magnetite, which forms chain and lantern's texture. Okay. Yeah, these are the way. These kind of pictures. I don't know how them. It's photo micrographs. And they have the possibility to put in this kind of measurement here. I don't. Now I don't know how they get this color forth. There are probably many possibilities. So it would be very interesting to get this kind of analysis of this stone I just showed to you. Because we approximately know what it contains if it is number 7. If it's not number 7, then we just watch some other stone. But we don't know. Serpentine. This looks like this other stone I showed. In a way. This white stuff. MT. What was MT? Do they tell MT? What picture it was? F. Relict of primary clinopyroxenes. No. Yes, clinopyroxenes within its altered mass of tremolites. I'm talking about this feature here. Because it reminds me in a way of this, which is from another stone. There is something. There is many somethings here, all over the place. It has a shell or something, a layer. It probably interacted electromagnetically in its creation, that's why it has this double layer of whatever. But I think that's very fascinating. Squares. They're almost squares. Yeah, you could measure them. Not all of them are, but there are a few. But anyway, now we have watched many pictures and I've been talking. Enough. I saved the world and shut up. So I won't emit more CO2 than necessary. Probably I won't shut up. But anyway, thanks. Bye.